The future of standard medical practice might be here sooner than anticipated, where a patient could see a computer before seeing a doctor. Through advances in artificial intelligence (AI), it appears possible for the days of misdiagnosis and treating disease symptoms rather than their root cause to move behind us. You're watching your favorite YouTube channel. In today's video, we are going to talk about artificial intelligence in medicine. Before moving forward to discuss, make sure to subscribe to the channel and hit the bell icon, so you won't miss any future videos we upload. Despite the immense improvement in healthcare over the last few decades, doctors still make mistakes on the epic AF TV show House DR, because doctors are still humans, so they can still diagnose and treat diseases more efficiently. There is no doubt that House is far more brilliant than his colleagues, which implies diagnostic mysteries and unnecessary deaths in hospitals would drastically decrease if all doctors were as smart as him. But in reality, the biggest difference between doctors is not their intelligence, but how they approach patient problems and the type of healthcare system that supports them. This combination leads to such wide variations in clinical outcomes, which is why machine learning is the best solution. It is possible to improve doctors' capabilities by joining them if you cannot beat them. Studies have shown that more than half of all women in the US get at least one false positive, which is a test that incorrectly indicates the possibility of cancer over a 10-year period. AI can do something that no radiologist can, as radiologists routinely disagree on the interpretation of medical images. With the advent of cheaper computing power, the accuracy gap will only grow as it can learn from hundreds of thousands of medical images and is estimated to be up to 10% more accurate than the average radiologist. In addition to radiology, which is what Vigiai is doing for brain scans, doctors also have to interpret patient medical records, which can be a very challenging task. In NLP, a branch of artificial intelligence that enables computers to understand and interpret human language, thousands of medical records can be reviewed and optimal steps can be generated for assessing and managing patients with a wide range of illnesses. By watching the best doctors do their work, artificial intelligence can learn from them. If all doctors did their jobs as well as the top 20%, death rates from different diseases would decrease by hundreds. With thousands of patients per year and wild doctors with natural biases, AI is more likely to make objective diagnoses without preconceived socioeconomic assumptions, resulting in disparities in care for patients. The ML will become a crucial tool for doctors like the stethoscope, and as more and more of medicine becomes automated, empathy and compassion for patients will be critical to their success in the field. Also, good looks. Let's be real. What can we do? According to research in markets, the AI and healthcare market will grow by an astounding 48% compound annual growth rate in the next 5 years. There is no doubt that Google and Microsoft have a huge advantage when it comes to building horizontal products due to their massive data talent and computing power. These products can be applied to a wide variety of use cases, but as a startup you can build a. One way to find relevant problems in online communities where doctors congregate is to find ones that tackle a single problem well, since they lack time to do so. These can be forums, Slack channels, subreddits, or Grey's Anatomy chatrooms about McDreamy to find out what kind of problems they're experiencing. Another alternative is to call up or schedule a visit to a local practice to get first-hand information. In order to find the right problem to solve, we need to listen before acting. Eventually, we'll run into problems that are handled by multiple doctors. For example, in this demo it is diagnosing diabetic retinopathy correctly. We can build a classifier to help solve this problem. But first we have to get some quality data first, because machine learning relies on lots of data. It's only through quality data that it learns. Despite the difficulties of collecting this type of data from patients, very few companies actually generate and own medical-grade data, so we'll have to be creative. We can search the web for public imaging data sets for diabetic retinopathy. We'll find a few, but some will require us to register and apply to get access, so we can do that and hope for the best. In addition, if you're a student at a university, you can go to the Imaging Research Center and ask the professor for help. PubMed is also a great place to search for biomedical research papers. We can look for papers based on the skin data we want, and once we find a good one, we can contact the researchers directly to explain our project and how it could benefit both parties. If we frame it more like we're trying to help them than asking for something, they'll be more likely to help us if we can get our hands on a quality dataset, preferably with labels, because labeled datasets are always easier to learn from. We know that we have a chance at solving this problem, but before we actually invest time and energy into building an AI model, we need to make sure that we're able to get customers the easiest way to do this. We will create a simple landing page. You can find a template online that asks for an email sign. We would describe our product and create the landing page, and once we have it, we can send it to potential clients, in our case doctors and medical companies. We can find a directory of them online, email them one by one, post it in Facebook groups, and see if we get any signups if we're able to get her. We can begin building models once we have enough signups, so we can be sure there is a lot of interest. We have access to an ecosystem of libraries and services that help us build models. Kaivi Sanity is a great tool to help us search for how the latest AI models have been applied to medical diagnosis in research labs. Once we find a cool paper, we can use it as a guide to help build our own model. Several tweaks and modifications could potentially be made to our model to improve it. But the best thing is to build a prototype that works as quickly as possible first, and then iterate from there. Convolutional neural networks have been proven to outperform all others when attempting to classify images, which is our use case. The Chaos Machine Learning Library is the fastest and easiest way to build convolutional neural networks. With its high-level API, we can build neural networks quickly. Each line corresponds to a different layer in our neural network. For example, if you search GitHub for an image classification chaos model, you could use that as a base model. Notice how the parameters seem like magic numbers. How do we know which numbers are optimal? That's why deep learning exists. It is often a simple tweak that gives rise to a breakthrough in accuracy that is the focus of research papers in this field. So we can use the parameters of the paper we chose as a starting point and train this model on our dataset. I have a MacBook Pro. I love Apple. Let's collaborate. Okay, thanks, bye. I did not have a deep learning rig, so I decided uploading my model to FloydHub, which is a platform for training deep. The cloud can be used for learning models in a matter of minutes with just a few commands. The purpose of the algorithm is to learn the mapping between the input data, medical images, and the output data, which are the diagnoses of the images. Once it has learned this pattern, it can accurately predict the diagnosis of a new image. Once it has been trained, we can use FloydHawk to create a basic API call where we merely send an image, and it will. With any web framework of our choice, we can build one web page that asks the user to upload an image, and it will call the API to return the prediction for the user to see. From here, we can add a beta design, make programmatic improvements, and finally start getting sales. I've got 3 things for you to take away from this video. I can help doctors approach patient problems more effectively, improve diagnosis, interpret patient medical history, and discover drugs are just a few of the potential uses of AI in healthcare. And we can build a simple model using Kairos Deep Learning Library and train it. That's all for today's video, guys. What do you think of today's video? Tell us your views in the comment section. Thank you very much for taking the time to watch this video. See you in the next video. Until then, best wishes.